Hey everybody, welcome to Welding Wednesday. This one's about welding history. Let's get into it. We're going to talk a bit about the ancient beginnings of welding, Middle Ages and the Renaissance, the Industrial Revolution, kind of modern era, what's happening now, and then overview of what constitutes our welding and cutting processes. And review it all up, and we'll be done. So to start out with ancient beginnings, if we go back to Bronze Age, which started about 5,000 years ago, so 3000 BCE. If you're wondering, BCE stands for before Common Era, CE is Common Era. So if you've not seen that type of time like numbering system before, that's what that stands for. So likely originated in Egypt. Some of our first metal joining initially used to join like jewelry, utensils, weapons, that sort of thing. Up top here we see what looks to be a fellow casting a sword, I believe. Up there, probably out of bronze. Forge welding was used a lot, so that's very similar to like blacksmithing that we do nowadays, where you're taking two pieces of metal, you are heating them, and then using pressure from hammering to actually join the pieces of metal. The forge welding is what was used for quite a long time. Modern welding, like with arc welding or anything like that, same type of principle where we're going to be heating the metal and using pressure to join it. In the case of arc welding, we're using electricity. Forge welding, it's human power. And then there was also hard soldering, so that was used to make swords by Sumerians in which is modern day Iraq. It's called hard soldering because that's a reference to the melting temperature needed to actually make the solder. I kind of liken it nowadays like soldering, brazing, welding, where they all are different ways to join metal, but it all has to do with the temperature that the metal gets to. And we'll definitely talk way more about that as the series progresses. Moving rapidly into the Iron Age and Common Era, so starting about 3,000 years ago, so about 1000 BCE. In China, we have the Sui dynasty, or Su, not 100% how to pronounce that, but we'll go with Sui, from 600 BCE. So that was where one of the first occurrences of turning wrought iron into steel. So if you're not familiar with wrought iron, that is iron with very low carbon, usually less than about 5% or so. Steel that we use in almost anything goes from about 1 to 2%-ish, depending on the type of steel. And then once you get past 2% carbon, we're going to get into our cast irons. So we'll talk later on about like metallurgy, things like that. Carbon is the ingredient for our steel that really helps us to be able to use it in most modern applications, because that's what gives it strength. Pliny the Elder, who was a Roman naturalist, philosopher, commander in the Army and Navy, basically did everything, it seems. In the year 1, first written description of a brazing process, and he described how salts acted as the flux. So if you're not familiar with the flux, that's what's used to kind of help. One of the things that's used is to help like clean contamination out of the metal, and then also protect the metal when it's heated from the atmosphere. So he was one of the first to describe how salts act as a flux, and then how metal color determines the brazing difficulty. So if you've worked with steel before and seen like some of the steel is like blue, some of it's shiny, some of it's gray. That all has to do with different levels of oxidation based on the different ways that the steel was produced, and that can all affect how well it can actually be joined together. And then another example we have of some really impressive, in my opinion, metallurgy and technical skill is forge welding of the Iron Pillar in Delhi, India. That's the year 310. It's 5.4 metric tons, about 24 feet tall. First constructed outside of a temple for Vishnu. Really shows off a high level of skill for Indian ironsmiths. Also, like a great example of, or one of the most important objects maybe of Indian cultural and spiritual heritage. One thing that kind of blows my mind is the type of iron that's used in this is corrosion resistant. So it's kind of similar properties to a brand name like Corten or weathering steel, except it was made, 1700 years ago. So really impressive stuff. Keep on marching through to the Middle Ages and Renaissance. So Middle Ages, so started about 1400 years ago or 600 CE. It's the first time we see blacksmith being used as a title. So the word blacksmith comes from black, which references like the oxidation of iron and flame. We know that slow oxidation of steel or iron is red, that's rust. But rapid oxidation is usually much darker, black, dark blue, that sort of thing. So the black is distinguishing that this person is different than other metal craft workers because they're working with like oxidation of iron. And then smith is derived from the word to strike or hammer. So that blacksmith is someone who hammers iron, basically. We saw Smith as a surname in writings around the year 975 CE, so that means that blacksmith was at least a term pretty close to that sort of time. So yeah, about a little over 1,000 years old. And then in 1000 CE, Theophilus, who was a monk, or more accurately probably, it's this pseudonym of a monk who was writing to, just looking at my notes here, I want to make sure I get this right, wrote this like big compendium of medieval arts. So he, or they, were the first people to have a description of flux used for silver brazing, and basically like a recipe for the flux, which at that time was a mixture of sodium chloride and potassium tarpate. So yeah, about 1,000 years ago, we start using blacksmithing, and we're getting some recipes for things. In the Renaissance, which was about 700 years ago, 1400 CE, 650, 620, 620 years ago. That's where we first see the origin of the word weld, and this one it really amazed me. So we can find the word weld if we look at old translations of the Bible. So in the 14th century, the English translation of Isaiah 2, verse 4, so chapter 2, verse 4, they shall beat together their swords into plowshares. If we compare that to a translation 200 years later, in the 16th century, where the same verse is translated, they shall weld together their swords into plowshares. So sometime in that 200-year span, the word weld began getting widespread use. So widespread that we're going to be using it in the Bible now. So it had to have been a very popular term, or at least a well-known term at the time. In 1540, we have Venancio Berguccio, nailed it, I know I nailed it, who had the first printing of a metallurgy book called De La Pyrotechnia, which is an awesome name. Great name for a band, anything like that, for those of you looking out there in the world. All right, continuing on, we'll go into the Industrial Revolution. So it started about 250-ish years ago. We have the discovery of the electric arc by Sir Humphrey Davy in 1808. Really changed everything. I don't know if we can say that he discovered the electric arc, maybe learned about it, because it was around before him, but, learned how to, generate and control it. Invented this thing called a Davy lamp, I believe, yep, which was an early electric arc lamp. Other things that old Humphrey did was the first to isolate some elements using electricity. So he was the first to isolate potassium, calcium, and sodium, and a bunch of others too, but those are some pretty major ones. His cousin Edmund was also no slouch in this department, at least chemistry and whatnot. In 1836, he discovered acetylene. So he had processed some carbon, potassium together, made potassium carbide. And then once the potassium carbide is exposed to water, it releases acetylene gas. So if you didn't know, that's how acetylene's made. Another thing we'll talk about more later. Let's see here. Oh, another thing Edmund did was came up with the idea of, or at least explored, refined the idea of using sacrificial anodes, like zinc anodes, to help prevent corrosion, specifically galvanic corrosion. And corrosion is something that is crazy fascinating that we'll also be talking about later. Arc welding was starting to get established then, kind of developed in the mid-century, but did not gain wide application until late 1800s, and that brings us to the modern era. So if we look about 150 years ago, we'll say is the modern era, about 1850, we have Auguste de Meritens from France, first to fuse lead plates with an electric arc. Here is the carbon electrode apparatus at the bottom here that was used. And then Nikolai Slavyanov from Russia in 1888 pretty much invented, I guess this is a little wrong, really didn't invent shielded metal arc welding, but did invent using electrode with welding. It was the beginning of shielded metal arc welding, because then in the 1900s, more coatings were introduced to be able to cover that bare electrode. So carbon welding, using a carbon electrode, that was about mid-1800s. When we start using a like filler metal steel electrode, that's what Nikolai kind of did, and then we developed more coatings and fluxes from there. There was a resistance process developed too, so we have seam, spot, flash, projection. We're going to be talking a ton about different processes as this series goes on. You can kind of divide the welding processes into different categories. So arc welding, we're using an electric arc to actually melt our metal, provide that pressure for welding, that sort of thing. With resistance processes, we're using an electric current. So we have pieces touching each other. Let's see if I can do a little drawing here. Yeah. Okay. So let's say this is piece 1 of metal. Ooh, perfect. And this is piece 2 of metal. And then we have our electrode here kind of pinching. So this is kind of like a spot weld. So these are the arms. Electricity is going through the 2 points. And basically with resistance welding, where there's resistance in this connection, which is usually where these 2 plates meet, that's where the current will start to melt, and then from out there we'll melt and actually make our weld. So that's the main difference if you see resistance versus arc welding. Arc, we're using electric arc. Resistance, we're using basically electric current. Moving into the post-World War era, so about 100 years ago, World War I started in 1911, right? I think 1914, and then to 1918, and then World War II, U.S. involvement 41 to 45. So beginning of the World War era, post-World War era, about 100 years ago. Special shout out to local college, Dunwoody College Technology. They had their first welding classes in 1915, which makes them one of the oldest welding institutions on earth, right along with Lincoln Electric, who I believe they had their first class in 1917. So Dunwoody is still teaching to this day. And a little background on me, real quick. I actually taught there for 5 years, so pretty good school. But anywhere you go for welding education, that's a good idea. We have the American Welding Society that was founded in 1919, the authority for welding in the United States, and also, heavily influences many things as far as code standards, regulations, terminology, safety, best practices, basically everything you can think of associated with welding and metal joining. We have P.O. Nobel in 1920 who started automatic welding, so what we would call like GMAW or MIG, the very early part of that. It was truly just like dispensing a bare wire electrode, so you didn't have any shielding gas that we use now. It was used a lot for repairing and molding like metals, but you can imagine there was probably a lot of porosity, things like that. And if you don't know these terms, we'll learn them all as time goes on. In 41, Piper and Meredith, they invented heliarc welding, used for a lot of like aircraft stuff, things like that. World War II. Heliarc welding is better known today as TIG or GTAW, but yeah, initially used helium as the primary shielding gas for that. And then in 1950, so about 30 years after Nobel started it, we introduced gas-shielded MIG. So that's where we're using CO2 first as the shielding gas, used to weld thinner material, get a lot better results by preventing that atmosphere from getting into our weld. If we look to the 1960s and now, another AWS thing, our American Welding Society thing, is the first edition of D11 came out in 1976. D11 is the structural code for welding steel. I don't know, pretty close to a Bible, I guess, as far as like how to put things together structurally with steel, and how to do it correctly, how to make sure people understand like what's been done with engineering to make sure you get a good result, all there. So latest one came out in 2020, I believe, so there should be another one coming out here pretty darn soon. If you know anybody who's a CWI or certified welding inspector, this is one of the very primary documents they'll be using for their work. There's been a big increase in digital and automated solutions as time goes on, taking a lot of things from analog into digital processes. We think about like machinery, like welding machinery. A lot of it used to be like big transformer systems. So basically the changing or adjustment of your electrical power was done mechanically. Now a lot of that's done digitally, and we use things called inverters. They're a lot, usually lighter, more portable. You can do a lot more with them as far as like adjusting the different settings and how the electricity flows and how we use it, but they are also like, they are way more expensive to like fix a lot of times too, or even buy on the onset, just because so much of it is controlled by digital aspects, so circuitry. When I was teaching back in the day, I would always tell like students that the old ways are always more reliable and the new ways are always more efficient. So you can, when it comes to like learning the technologies, things like that, it's a great idea to understand them both, because you can always go back and use the reliable stuff. But if your new efficient stuff's working, great. That's what you should be using. Some new processes that are kind of fun are like laser processes. So down here in the bottom, we have a picture of a Optex laser. We actually have one of these at our Minneapolis store. So if anybody wants to do a demo or anything like that, get a hold of us. We'd be more than happy to do it. I personally think laser is going to be huge. But talking about the codes and standards that we mentioned on the last slide, that's one of the impediments at the moment. Laser produces super fast welds, super high quality, but there's not a lot of code approved applications yet, so it'll take a little while for things to catch up, but I think it's going to be super popular. Magnetic pulse, we actually use magnetism to do our welding. Electron beam is one of my favorites. That's here in the other picture on this slide, where we're actually focusing like individual electrons basically to do our weld. That one is crazy. Like the temperature of the welding is like 180,000 degrees or something like that. It's really intense, but it's really cool. Friction stir is another one of my favorites, is where we actually like stir material together. So we don't fully melt it. We turn two pieces of base metal where the weld joint will be. They just, through friction, will get to a plastic state. And then if you think about it, let's say you're like, I don't know, mixing like cookie dough. It's the same type of thing, really, is we're mixing the metal together, and since we're not like melting it in the same way as we do with other welding, we have way different results when it comes to the mechanical properties, which is super important to us, and again, something we'll talk about a lot more later. All right. So we talked a lot about history. Now we'll just look at very briefly what we're referring to when we're talking of welding and cutting processes. The pictures on this slide are actually of some friction stir welding, as I was talking about in the last slide, where you got like this little like probe. Basically, it's got this tungsten pin, and yeah, through friction, we're just going to be plasticizing and then melting the material together instead of well, not melting, mixing the material together instead of melting it. This chart has about, I think, 130-ish different processes. So this includes welding, joining, and like thermal cutting processes. So everything kind of related to hot work, you would say. Welding specific, there's maybe like 55, 60. New ones are getting invented all the time. So if inventing new welding processes, new joining methods is something that's interesting to you, going into engineering, so either like a materials engineering, maybe welding engineering, things like that, help develop these, which would be pretty cool. We will mostly be focusing on, as this series progresses, 4 arc welding processes, which I kind of call the big 4. So that's going to be your stick or SMAW, MIG or GMAW, TIG or GTAW, and then flux core or FCAW, and then also oxy-fuel welding or oxyacetylene welding. So that's kind of like the big 5 for most of our customers and a lot of folks out there in the world. All right, review. So kind of walk through a timeline there. We got metal joining. Historically, we've seen it for about 5,000 years or so. Started out with forge welding, so right down here in this photo, just heating metal and beating it with a hammer. Did some brazing, some soldering. Then we get into actual welding, where we're completely melting our material, joining it, and making a new piece. If you have any other questions, suggestions, things that you would like covered in a future Welding Wednesday, please let me know. I would love to hear them and love to get any feedback. Any constructive feedback would be great. Some resources that I use for this, Lincoln and Miller, they have excellent online education resources and many cool documents if you haven't looked at that. ESOP, same. James F. Lincoln Foundation is one of my very favorite things. That's where I got the Metals and How to Weld Them book. And then also I have it right here. There you go. The Procedure Handbook of Arc Welding. This thing is so useful, and the Lincoln Foundation offers them at very reasonable prices. So if you're looking to build out like a reference library, 2 of the books I would first suggest, and I think it might be like $50 total-ish, would be Metals and How to Weld Them, and then the Handbook of Arc Welding. American Welding Society, want to thank them also. Hobart Institute, also great information. Dunwoody College, super helpful for local folks in our area, especially with creating curriculum, things like that. They do a great job. Another book I love is Welding, Fabrication, and Repair by Frank Marlowe. Another great one if you want to add a 3rd book to your reference list. It's just a bunch of questions and answers on how to do stuff, and it's really, really well done, I think. And then finally, maybe the person who's most famous for writing welding textbooks, Larry Jeffess, that got a lot of information from those sources as well. All right, well, thank you for listening. Really appreciate it. If you need anything from Minneapolis Oxygen, give us a call. 5 locations around the state: Minneapolis, Ham Lake, Shakopee, Duluth, and Hibbing, and then tons of great services. So we're here for you. Appreciate it, and thanks for tuning in, and I'll see you at the next Welding Wednesday.